Okay, hello and welcome to this demo from the IOHK engineering team. My name is Rupert Horlick. I'm a Haskell developer on the Ledger team of Cardano, and I'm here with Duncan Coutts, the technical architect for the Cardano project. Today we're going to be showing a demo of... Oh, hello. Yeah. Today we're going to be showing a demo of the first integrated node in the Shelley era. So it's going to be targeting this first release we can see on this bottom arrow. It's going to be fully compatible with the old Byron rules and allow us to retire the old code base and move on to something that will allow us to move into the Shelley era. So what I'm going to do is pass over to Duncan, who's going to give an overview of the structure, the architecture of the whole node and how it interoperates with other parts of the Cardano ecosystem. And then after that, I'll give a demonstration showing a node running on my local machine. So let's start with the architectural overview. Duncan.
Okay, thanks, Rui. Yeah, so what we're going to be demoing today is the node, but yeah, this diagram shows what the node consists of, but also how the node interacts with other components. So the new architecture is a bit more modular than the old one. It uses multiple processes in places where the old one used a single integrated process. So the node, which is the box on the left-hand side there, it contains a number of components, and that's really what we're going to be talking about in the demo. But the node interacts with other components that we're not going to be demoing today. It interacts with the wallet backend and with other local clients, such as Explorer backends and other sort of third-party integrations. It interacts locally with command line tools, and we will demo today interacting with a command line tool for submitting transactions. And of course, the node talks to other nodes. So one of the things that we're going to be demonstrating is the network protocols that the node uses to talk to other components. Local IPC, local inter-process communication, for talking to local clients like a command line client, and also the node-to-node protocol, which runs over TCP. And Rui will be demonstrating this with multiple nodes on his own machine, but it is using TCP. So we can run this with multiple nodes on multiple machines, but just for the sake of the demo, it's easier for us to demonstrate that using multiple nodes using TCP on localhost. But it is the full networking protocol that is using TCP. It's just we're running that on localhost for the purpose of this demo to make it easier to show things off. So let's just briefly talk about what makes up a node, and what really is the significance of the milestone that this demo is demonstrating. What we've got is that we have this milestone is really about the fact that we have got the 4 major components of the node all integrated now. These are parts that we've been working on, in their separate parts, and they're now got to the stage where all of them are sufficiently complete, and we've got them all matched up and integrated against each other. And that's a very important milestone, because anyone who's ever done software development before knows that integrating is often the hardest part. So we've got there, we've de-risked that aspect of things. So what are the components? Right. So the 3 most important components are the consensus algorithms, the ledger rules, and the network subsystem. So the consensus is that is the implementation of Ouroboros. But the consensus is separated from the implementation of the rules of the ledger. What is valid data to go on the blockchain? What is valid data is what's determined by that's the difference between a cryptocurrency and a blockchain. A blockchain is just a data structure consisting of blocks containing information, and that's what Ouroboros is. It's an implementation that idea, a blockchain algorithm. But a cryptocurrency is, putting particular form of data on that blockchain, which is an accountant's ledger to say, who owns what, how money moves between different accounts. So we have a nice clear separation in our new architecture between the rules of the ledger and the rules of the consensus blockchain algorithm. So the ledger rules, that's what determines, that's what makes Cardano Cardano. It's as distinct from just being Ouroboros. That's where we explain how the UTXO system works and all the rules of what is valid data, valid transactions to put on the blockchain ledger. Then the network component obviously is extremely important. That's how the consensus system actually communicates with other instances of itself in other nodes. So the network consists of a number of different protocols that we run together over a single TCP connection between each pair of nodes. And that deals with getting blocks from node to node, and it deals with getting transactions in the other direction. So transactions are submitted towards nodes that create blocks, and in the opposite direction, blocks go outwards. In the demo today, we will not be demonstrating node-to-node transaction submission, just doing that in the local case, but we will be demonstrating, blocks being distributed, of course. Otherwise, there's really nothing to show. Otherwise, that's the most important thing in the consensus is the blocks being distributed between multiple nodes. I will be demonstrating that with three nodes. The other aspect that the networking covers is actually local IPC. So we have more or less the same scheme for node-to-node communication and node-to-local client communication. It uses a very similar design. So yeah, it might be slightly confusing to think of network as being IPC, but networking is just remote IPC. So yes, that's the networking subsystem. So yeah, a summary again. The crucial thing is that we've really integrated those three components. Now, what's the other part? The other part is ancillary extra services that are beyond the three core components, and those are needed to make the system run and to be easily to get logging information and monitoring. So what we call node shell is a shell because the idea is it's a kind of thin layer around the outside, like an eggshell maybe. It provides the sort of container in which all the other components run, deals with starting them up and shutting them down and monitoring things. It deals with configuration files, passing all the right configuration to the right parts. And it deals with logging and runtime monitoring. So we've actually got some rather nice features that operations people I think will be quite happy with for monitoring the status of the node at runtime and getting lots of varying levels of detail of information about what's going on. And we'll demonstrate some of that today. So yeah, that's the overall scheme. And I'll hand back to Roo to show us it actually running.
Great, thank you. Okay, so I'm just dropping here into a page on the wiki of the Cardano node repository, which is where we pull together all of these different components. This page is going to remain here as it is to be a historical snapshot of this particular demo, and it's going to contain the tag of a commit so that you can come here and you can try running this for yourself exactly the same way that we're running it now. So as Duncan said, we're going to see all the different parts of the system connected together and communicating all on one machine, but actually using TCP protocols. So we're going to have three nodes, and they're going to be running the BFT algorithm. So this is a sort of consensus algorithm where the different core nodes sort of go around in a circle and publish blocks. and it's extremely simple, and this allows a really simple compatibility between the old code base and the new code base. So that's why we've implemented this very simple thing in this transition period. We are going to submit some transactions. We're going to see those get adopted by nodes and then shared around amongst the 3 nodes so they reach consensus. We're going to watch some of the transactions fail when they're invalid, and we're going to be able to see the logs as all of that happens. And that logging is going to include logging coming out of various bits of the system. So yes, this shows us that we've got these nodes that can run independently and communicate, and they can do real transaction submission and have real mempools that take transactions, put them into blocks, and share them out across the network. And that's the gist of the whole system. And so from now, we're really just refining that to something that is ready to be taken onto a test net eventually, and then released out into the world. So the next step.
It's perhaps worth noting here that although we are using the BFT algorithm here, this isn't just for the purposes of a demo. The BFT here is, as we mentioned briefly, is the real thing that we will be running on mainnet for this period while we are handing over between the old implementation and the new one, before we move into the Shellier era, where things become fully decentralized and we move to the Ouroboros Preos algorithm. For people who haven't watched some of the previous videos, there's this intermediate stage in the transition between the old and new, where we use this simpler intermediate BFT consensus algorithm. But that's not just for the purpose of this demo. That is, the real thing that we really will be running on mainnet. And the same with the rest of the ledger rules here. These are ledger rules that are, we already know are attested to be compatible with the existing Byron mainnet. So, these are the real things, real transactions. There's not, we can run these demos with like mock crypto and mocking out certain parts, but this demo we're showing all of these parts, the real thing. Not there's no. I don't think there's any remaining mocked parts here at all. In fact, unless I'm forgetting anything, Roo?
No. The storage layer is in memory, but
That's
it's
true.
not.
Yes, that's true. Yeah.
Not a mock, and it's still storage of some kind. Just not very good.
Yeah. So I think at the end of the demo we'll come back to what are the next steps for the the immediate next steps after. So we'll talk about the
good idea.
Storage layer and some of the things like that. Yeah.
Okay, so let's jump straight into the demo then. Here we have my terminal, and I will first of all drop into the Nix shell that will prepare my dependencies. I need to get tmux open, which allows us to see multiple nodes running at the same time. And so we run tmux new session. I'm going to just call it demo. So from here, we will run our demo script. And we're suddenly going to see multiple different nodes pop up, and they're going to start running a whole bunch of text, which is logging what they're doing behind the scenes. So here we go. So in the 3 panes that have scrolling text, those are our 3 nodes. You can see they each have their own ID. There's core ID 0 in the top left corner, and then 1 and 2. And right now they are all producing empty blocks, and you can see that the chain is growing, and each one of them is producing blocks in turn. So they're, so not very interesting to see empty blocks, so let's try submitting a transaction. We're first of all going to try a transaction that should fail because its value is too large. And we will see the error from the real ledger rules that shows us that it doesn't work. So we get a bit of a strange error here. It says there's been some underflow in the fee, and this is because the value is too large and it wasn't able to calculate the fee properly, and hopefully there would be a less cryptic error message if we had this kind of error, but that's not so important right now. Next, we'll try and submit a transaction that should work. And we want to see the transaction be submitted to node 0, as it says in our command. -n0 means node 0. And we are hoping to see it be accepted, and then we want to see it propagate across all of the nodes. So yes, in our slightly strange log output here, it says transaction rejected, nothing, which means there wasn't an error. That should be tightened up, but that's okay for now. And you can see that there's now a transaction in all three of the chains here. You can see there's sort of TX in, TX out, somewhere in the middle of the wall of text, and that is our transaction. It's slowly being moved further and further back along the chain as new empty blocks come in. So I'm just going to kill all of these now and scroll back up in node 0 to see where the transaction was submitted and show that it was entered into the mempool of this node, and then it was published in a block. A bit further back. There's a lot of output here, and all of this logging is configurable, and we have big plans for all sorts of interesting ways to do the logging, including UIs and profiling. But right now it's just a big wall of text. So you can see there it is as the last block in the chain, so that means that the mempool submission should be up here. So we can see, first of all, we had a TX submit, so the transaction was given to the node, and then we had this add transaction to the mempool tracing, and then you can see the block, as the leader in this slot, this node produced a block containing that transaction, and then of course it had to remove that transaction from the mempool because it had actually been used. So you don't want to try resubmitting that transaction once it's actually been published. And then that becomes the tip of this chain, and then we saw that it ends up here in the chains of all the other nodes, and so they're achieving consensus on that transaction, and that's all being sent across the network, and it was submitted from across the network from another client program. So yes, that's seeing all of the nodes communicating over the network, moving transactions around with a real mempool and real ledger rules, and achieving consensus. Any questions?
It might be worth pointing out that the fact that for the demo, the slot length here is being reduced from what it is normally. That's why the chain is going very quickly.
Okay.
Normally every 20 seconds, right, for PBFD.
Yeah, that's right. Did we also want to show the last, did we want to show the example of the transaction being rejected for the double spend?
Yeah, that might be worth showing.
The UTXO input error. So, as in, start them all again, and then pick up. So there was a nice pause, so we can do the edit. It'll be fine. And this little bit where we're talking can get removed, and just pick up from there, and restart the nodes, and do the final one with it being rejected. I guess it starts from empty each time, so you'll have to do it first accepting and then rejecting. So that.
But I think it's even fine, even if you say let's to make continuity in the video, you could say let's start this again. let's see it submitting, and then let's see what happens if we see the exact same thing again.
Yeah.
Submit the exact same thing again, and then let's see that it gets rejected because of the double spending.
Yeah, and you
Yeah,
you can
okay.
interject in the middle of that, as commentary. Edsko's point about for the purpose of the demo, it's running more blocks more frequently than we do in mainnet.
Brilliant. Okay. So
Right.
I
Yeah,
will.
although we could even leave that in, right? I mean, you ask, are there any questions? I mean, there's no, it's okay, right, for me to say that?
Absolutely, yeah, of course it is.
There's no need to re-record it, I mean.
No, that's that. It's totally fine for it to have a Q&A aspect to it. All right, I will
I
shut
just
up
thought it might
again.
be worth pointing out because it's growing
Yeah.
very quickly and it's might be leading to
Yeah.
some- where somebody who's actually paying attention.
It's true.
So for the demo video, you're saying keep your question in there.
Yeah, I would say so, yeah. I
and
mean, the
your
whole point
answer.
that I'm here is that you have a bit of company, right?
Yeah.
Yeah.
So okay, so the bit we'll re-record, or the bit we'll record extra then will be Rue showing a transaction being accepted and then rejected, what for the double spend
Right.
input.
Yeah.
And
So then we'd cut out the bit of you saying that we should do that.
Yeah, exactly. And then Rue, you
But
ask
keep
again any other questions, and Edsko can make this comment about the transaction, the slot length.
However,
Or-
you have now shut down your windows, so there will be discontinuity in the output on the screen. So you'll need to,
That's okay. Just
yeah, that's fine. You'll need to explain what happened.
yeah.
Oh. Good point.
Oh, it's not a big deal. It's just
No, it's not a problem at all.
Okay. Okay. So.
Okay.
silence
I will
for a second,
shut up.
and
I'll shut up again, and then we can go. Yep.
Okay, so I've just closed down the nodes so that we can start them up again and try seeing what happens if we try and submit the same transaction twice. So if we run our script again, we should get our nodes back. We are running with in-memory storage here, so all of these nodes will have to start again from an empty chain, as you can see. And now we can try submitting that transaction, which we expect to be accepted. And it was, you saw it there flash up on the top left corner. And now it's in all of the chains. And it's worth noting here that the chain is moving so fast because we're in the demo, and you can see we've got here slot duration 2. So this is much faster than it would be in the real chain. Now if we submit the same transaction again, we expect it to be rejected because we should not be allowed to spend the same transaction twice. And there we go. So it says UTXO missing input. So in the ledger we've removed that input, it's been spent, and so it's no longer in the set of unspent transaction outputs. And so it was rejected as we expected. Yeah, so up here we've got sort of our immediate next steps. So there are some limitations. There's a wiki page that captures the current state of things that will be updated over time. But right now our storage layer is all in memory. We aren't quite able to run this node with mainnet because we're missing epoch boundary blocks, which were sort of an artifact from Ouroboros Classic that we need to take care of. And as Duncan said, we're currently only doing local transaction submission. So getting these three done, so completing the storage layer, that's almost there, but we need to continue doing some testing, lots of good property testing to make sure that that's working well and is working under all sorts of different interesting failures that we can produce. We just need to take care of these epoch boundary blocks. They just are an extra little bit of data in the chain that we need to handle. And then we need to add a remote transaction submission in the networking layer.
Yeah, so all these things are things that have been in progress in development for quite a while, and we're just sort of the final steps of integrating of all these parts. So the storage, we're expecting, and the EBBs and the transaction submission probably all within the next couple of weeks will be integrated with with what we have showed here, and then we'll be able to demonstrate all those things integrated together.
Mm-hmm. And then do you want to talk a bit about the integration with the wallet?
Yeah, sure. Yeah, so the wallet backend will be able to start its integration with the node almost immediately, actually, from where we are with this demo, because although we haven't shown it in this demo, the node to client protocol is fully integrated. What we demonstrated just a moment ago was using the transaction submission component of that protocol, but it in fact also supports the chain synchronization protocol with local clients, and that's what the wallet needs to be able to follow the blockchain from the local node. So that will enable the wallet backend team to start the integration with the new node. And yeah, I mean that will take a little while. There's a few things to do there, but that will kick off yes, very shortly.
Mm-hmm.
Yeah, I think that's all there is to say about the wallet integration for the moment.
Great. And then yes, we also have lots more testing to do, but in the spirit of integrating early, we didn't want to get all of our tests in place and get everything perfect before integrating. So there's plenty more testing to be done before we hit mainnet, and we're really sure that we've made something great. But we wanted to get something that we can show and something that we can start putting also on a testnet at some point soon. So
yeah,
by having a node in place, DevOps and QA
while.
can start to do integration testing and all that good stuff.
Exactly. Yeah.
So
yeah, so I think that's the upcoming integration. So we'll have another demo a bit like this in a couple of weeks or so, and be able to show this next batch of things having been integrated and show the progress.
Yeah. Any last thoughts before we sign off, or?
No, I think we covered everything really.
Great. Well,
yeah.
Thanks for joining me, Duncan, and thanks everyone for watching. Please do go and try out the demo yourself, and get in touch if anything's not working or anything's unclear, or file an issue maybe. And yeah.
Yes, I suppose we should warn that at this stage we haven't yet put that much work into documentation. That's something that we will start to make improve, so that our quick start guides are a bit easier to follow and whatnot. Particularly as we start to do these public demos. So if you don't get everything working for this demo, we'll try and get our quick start docs improved for the next demo.